Hey everyone, another quick curve sketching video. Here we're going to sketch the curve x minus 3x to the 1/3. First off, the domain of f is actually every real number, believe it or not. You're allowed to plug anything into odd roots. So cube roots are fine to have negative numbers because the square root of the cube root of -1 is still -1. So we're actually okay on that front. There aren't any vertical asymptotes. We're never dividing by 0. And also, to find any possible horizontal asymptotes, take the limit as x approaches infinity and negative infinity. Always remember that. And I think you can just see that, right? X is the dominant power. It wins out. Right, that's going to equal negative infinity. So f has no horizontal asymptotes. Right, so if you're really sharp with your limits and you're good with your, I guess, your odd roots, then this should take you no more than a minute or two. Okay. Now let's move on to our calculus. Stuff gets a little bit more dicey. We're taking derivatives of roots, right? But as always, we're going to let f prime of x equal 0. We're going to find our critical numbers, our critical points. And then we're going to hold off on the other interval of increase and decrease and local max and min classification until after we do the second derivative. So we can nail the concavity stuff and sketch the curve and get the shape in one shot. F prime of x is going to equal 1 minus, so 3 times 1/3 is going to equal 1, x to the negative 2/3. Okay, which remember is 1 minus 1 over, you can look at this as the cube root of x squared if you'd like. And we're going to let this equal 0. Okay? Now, it is worth noting right now that f prime does not exist at x equals 0. You can write that now or you can write it later. I'm going to write it a little bit later. Right? So at this point, we just want to, work toward, just solving this thing right here. What I'm going to do, I think, is multiply the left and right hand sides of the equation by the cube root of x squared. So we're going to get the cube root of x squared minus 1 equals 0. And by the way, that's the same thing as saying that the cube root of x quantity squared minus 1 equals 0, which is equivalent to saying that cube root of x plus 1 times the cube root of x minus 1 equals 0, which implies that the cube root of x equals -1 or 1, which implies that x equals -1 or 1. Also, f prime does not exist at x equals 0. Again, right, because we are dividing by 0. All right, so f actually has 3 critical numbers and 3 critical points. Because even though f prime doesn't exist at 0, f does. So f has critical points 0, 0. -1, plug that in, and we get -1 minus 3 times -1. That's going to be 2, right? So I think we're getting -1, 2. And I think the last one is going to be 1, -2. Okay? So now, let's go on to the second derivative stuff. Now, let f double prime equal 0, right? Take the second derivative, set it equal to 0. F double prime of x, now remember we're using this for f prime of x, is going to equal 2/3 x to the negative 5/3, which does not equal 0. And we should also say, note that f double prime does not exist at x equals 0, which should make sense because f single prime didn't exist at 0 either. Now, let's draw a line right here, get our interval chart going. Right, we know that -1 is a point of interest, an x value of interest. 0 is actually an x value of interest for both f prime and f double prime, and then 1 is also an interesting value for f prime and f double prime. Okay, so what we do when we plug in our values, I'll use green, why not? We plug values into f prime right here. Well, if we plug in a low negative number, the denominator is going to blow up. 1 over the denominator is going to get very small, and we've just got 1, which is positive, or something really close to 1, which is positive. Plugging in small fractions for x, positive or negative, they're going to get squared. They're going to make the fraction blow up. You're subtracting a big number. It's negative. We get a positive number if we plug in a large number for x. Now for f double prime, just to be clear, this is 2 over 3 times the cube root of x to the 5th. That's why it doesn't equal 0, by the way. But it also means that we've got a positive numerator and positive or negative denominator. So if we plug in a negative number for x, then we just get that. Plug in a positive number, we get that. So now we can describe what we've got here and then sketch our curve. F is increasing on negative infinity to negative 1, union 1 to infinity, and decreasing on negative 1 to 0, union 0 to 1. Please don't write negative 1 to 1 because that's not true. F is neither increasing nor decreasing at 0. The derivative doesn't exist. And I think we have both a local max and a local min. Local maximum is going to be f of negative 1 equals 2, and local minimum, f of 1 equals negative 2. Remember, they're y values. Look, maxes and mins are y values, so we have to write them as such. Okay? Also, f is concave up on 0 to infinity, and concave down on negative infinity to 0. And yes, f does have an inflection point, 0, 0. Even though the second derivative doesn't exist there, the second derivative still goes from being negative to being positive. It still changes sign. So we still do have an inflection point. 0, 0. Now let's sketch our axes and our curve. First, it might be a good idea to highlight the critical points, right? Because we got those. So now we just sketch our curve based on the interval chart here. Something like that, then that, then that, then that. And that's your curve y equals f of x.